I'm going to change the theme a little bit. Having said that CCS doesn't really actually capture anything, I'm going to talk about net zero and the need for CCS and greenhouse gas removal using both afforestation and BECCS, and also discuss a little bit the industrial enablers. Well, first of all, let's look at the relationship between climate and the atmosphere. You know, current mean global temperature is 15 degrees Celsius, but without greenhouse gas effect, it would be -15. So obviously in the pre-industrialized world, basically greenhouse gas absorption by the biosphere was balanced by its emissions from the biosphere. However, now natural absorption cannot catch up with emissions and atmospheric greenhouse gas concentrations increase. Therefore, less energy is radiated back out to space and the Earth warms. And really, if you look at the IPCC 1.5 degree report, you can see basically that the emissions, the cumulative emissions of greenhouse gases since the Industrial Revolution started is roughly proportional to the degree of warming in the atmosphere. So you see that if we are to limit the temperature to 1.5 degrees, we have only about 3,000 gigatons of CO2 that we can put in the atmosphere. And basically, we're climbing up that route. We're not slowing down the emission rate. So, you know, basically, we've only got a few years for that to happen. And if you look at that on a slightly different way, looking at the heating versus global heating versus time and the emission rate, basically we get to about 2030, 2040, we'll have used up our carbon budget, and we'll be way ahead of the global warming that we really wish to reduce to. So our emission profile should really look like this. We're up here now, and by 2050, we've got to get to zero. That's net zero, no emissions. But there's a problem. Decarbonizing anthropogenic activity is really a human quandary, okay? On one side, we've got the population increase. In order to improve living standards, we need more energy, we need more food for the increasing population, more transport, and also we have to improve the equity for the whole world. And on the other side, we've got climate change, and we've got the resources of one planet, basically. So if you look at all of the projections of energy use to 2050, and if we look at going to actually net zero, basically we would see that even if we get to net zero and we put a lot of renewables, use a lot of renewables, basically there is still going to be some residual coal, natural gas and oil for transportation, the things you can't decarbonize very easily. However, if you look at all of the promises made at Paris, the Paris Agreement, and you look at the current policies of reducing emissions in all the countries of the world, basically, if you take the projections of business as usual, if you like, and that's with all of the policies in place and the ambitions to invest in renewables that exist today, actually we're going to increase, we're actually going to keep emissions or energy use from fossil fuels fairly constant. And if you look at what I would call the emissions gap, if you take the stated policies emissions, it's going to continue like this. If you look at the emissions profile we really need to keep to 1.5 degrees, it looks like that. There is a small impact of COVID, which reduced emissions, but only by 7%. But even if we continue emitting at the same rate, there's a big emissions gap. And that, what are we going to do with it? We can't keep putting in the atmosphere because the atmosphere is going to heat, so we need to remove it. So if you look at the IPCC 1.5 degree report again, all net zero pathways rely on CCS and negative emissions from afforestation and bioenergy CCS. And if we look at the blue curve here, you see that that's what you need to achieve to get to 1.5 degrees. If you delay decarbonizing the atmosphere by increasing the amount of, say, wind power and solar power, the longer you do, the more negative emissions you need. And initially, if you actually can reduce emissions to net zero by 2050, then you'll need some sort of afforestation and land use change to balance the things that you cannot easily decarbonize, like food production. There's always some emissions from soil use and so on. The longer you leave it, the more CO2 you need to take out of the atmosphere, and the more, if you like, bioenergy CCS you need to extract, or DAX you need to extract the extra CO2. So it's a real quandary, and it's difficult to do. So if we look at the potential market size, looking at stated policies, you know, the IEA estimate there will still be 4 gigatons of CO2 emitted by 2050. And this is based on growth of energy, the stated policy scenario, and obviously some residual use of fossil fuel. Even if you go to net zero, the estimation is you're going to need 10 gigatons of CO2 per year of negative emissions, so that the budget, the carbon, and that's only if the carbon budget is not exceeded by 2050. And obviously you're going to have some residual transport and industry emissions because you can't capture it all. And also you'll have some agriculture emissions. So the potential market for CCS is potentially huge, depending on how well we do in actually reducing emissions. But I'm going to invent a new unit of CCS, and I call it a SNOVEAT. It's based on a CCS project in the Norwegian sector of the North Sea, which was put into place to reduce reduce the emissions of CO2 from separation of gas to make it saleable. And this actually stores about 0.7 megatons of CO2 a year. It consists of 150 kilometers of pipe, a capture unit, and also a large horizontal well into a saline aquifer. So if you look at that as my unit, the SNOVEAT, the UK electricity emissions currently is 184 megatons of CO2 a year. That's 250 SNOVEAT installations. If you look at global electricity emissions today, it's 15.4 gigatons of CO2. That's 20,500 SNOVEAT installations. And then if you are really going to decarbonize industry and everything else, you've got hydrogen CCS for transport, you've got industry CCS for cement and metal refining, and of course you've got these negative emissions that you require to balance the things that you cannot decarbonize. Now, just a plug for the oil industry here. And, you know, basically the CCS industry requires geology, it requires reservoir engineering, it requires deep drilled wells, requires building offshore structures, processing engineering, liquid and gas and liquid transport. And these are the strengths of the oil industry. And it can turn the oil industry from the carbon, you know, the climate change pariah into the climate change savior. But it has implications also for decommissioning, because the first consideration should be reuse for carbon storage. And this changes well abandonment criteria, and it requires plugs that are suitable for carbon dioxide, and they're not at the moment in most wells, and also it's suitable for repressuring the reservoir. And you also have to check the integrity of the cap rock. And in the UK, greenhouse gas removal must be scaled up fast to reach net zero by 2050. And this requires 100 megatons of CO2 a year. So you can see that's quite a bit. And if you want to do that by land-based greenhouse gas removals. You know, for 10 million tons of CO2 removal a year, afforestation removes about 3.6 to 13 tons of CO2 per hectare a year. So you need about 1 to 2.8 million hectares of mature forest by 2050. Or if you're going to do bioenergy CCS, now bioenergy plants can remove more CO2 from the atmosphere because they're more productive, that you need at least between 0.5 and 1 million hectares of perennial plants for 10 million tons of CO2. And the UK needs 100. So it's a very large area that you need. And the reason that bioenergy crops actually photosynthesize more is if you actually grow trees to maturity, they reach a kind of a stable, like before the Industrial Revolution, where emissions balance absorption from the atmosphere. Whereas if you just rely on this part of the growth curve, which is very steep, you end up being able to do that many times during the life of a tree. So you can actually get more energy, more CO2 out of the atmosphere. So in concluding remarks, CCS is technically feasible. Estimates in the UK was about $80 per ton. CCS costs are comparable to wind solar. Greenhouse gas removal will require large landscape changes, and there is a huge potential market unless we can decarbonize all of our activities much faster. And the skills will be available from the oil and gas industry, which will enable it to move from pariah to savior. The trouble is, it's got to start now. Thank you very much.
And thank you. So now we go on to our very last